Hi, hello students. In this video, I explain important problems in maxima and minima. So here we have an example. The maximum value of sin x plus cos x is, here we have four options. Now here we have a shortcut formula. Here we have to find maximum and minimum value results. See here first maximum result. See the maximum value of a cos x plus b sin x is equals to root of a square plus b square. So given result in the form of a cos x plus b sin x, the result can be written as root of a square plus b square. So now here we have the result. The maximum value of, here we have to find sin x plus cos x. So the maximum value, this is from the maximum value of sin x plus cos x, or see here cos x, here we have sin x, otherwise we can interchange the result, otherwise here we get the result cos x plus sin x. See here a is equals to 1, b is equals to 1 into cos x plus 1 into sin x is equals to root of 1 square plus 1 square. See here 1 into cos x, here also 1 into sin x form. See root of 1 square plus 1 square is equals to root of 1 plus 1 is equals to root of 2. See here observe options. Option A is correct option result. See next we try next example, second one. The maximum value of 3 cos x minus 4 sin x is. See now we know the formula. The maximum value of a cos x plus b sin x is root of a square plus b square. But now here the maximum value of 3 cos x, a is 3. Here we have minus 4. Otherwise we can write plus of minus 4. Minus 4 is b value into sin x is equals to root of a square means 3 square plus minus 4 whole square is equals to square root of 3 square is 9 plus 4 square is minus 4 becomes plus 4 square is 16 is equals to root of 25 is equals to root of 25 is 5. Answer is 5. Option D is correct option. So here we have next example, third one. The maximum value of 4 sin square x plus 3 cos square x is, option A is 4, option B is 3, option C is 7, option D is 5. So now here consider f of x is equals to given result is 4 sin square x plus 3 cos square x. See, we know the standard trigonometric function fundamental result. Sin square x plus cos square x is equals to 1. Sin square x plus cos square x is equals to 1. Now here we have cos square result. Now this result cos square x can be written as 1 minus sin square x. Cos square x is equals to 1 minus sin square. Now here we substitute instead of cos square x is 1 minus sin square x. Therefore f of x is equals to 4 sin square x plus 3 times 1 minus sin square x. Next step, this is result is equals to 4 sin square x plus 3 minus 3 sin square x. So here we have 4 sin square x minus 3 sin square x. Here 4 minus 3 is 1 sin square x plus 3 is f of x. Now here we have to find maximum value of f of x. See maximum value of f of x means sin square x plus 3. Already know the concept. See maximum value of sin x is, see we know the range of sin is minus 1 comma 1. See minus 1 comma 1, minimum value is minus 1, maximum value is plus 1. See maximum value of sin x is, maximum value of sin x is 1, which is attained. See here this is domain result or domain or range form. Maximum value we consider 1 and minimum value is minus 1. Range here we consider here minus pi by 2 comma pi by 2, which is attained at x is equals to pi by 2. The range is pi by 2, maximum value is 1. So this is domain result. Minimum range is minus pi by 2, minimum value is minus 1. Now here maximum value of sin x is 1, which is attained at x is equals to pi by 2. But what is the maximum value of f of x? Now here we have to find maximum value of f of x result, not sin x. See, suppose we get in the form of sin x, we can write directly maximum value is 1. But here we have sin square x plus 3, which is attained at the point, means range is x is pi by 2. Now here we substitute x equals to pi by 2 in this result first term. Therefore, f of x is equals to, or you can write maximum value of f of x is equals to sin of pi by 2 is 1. 1 square is 1. You can write as a result sin square of pi by 2 plus 3 is equals to sin of pi by 2 is 1. 1 square plus 3 is equals to 1 plus 3 is equals to 4. Maximum value of given function f of x. This result is 4. So option A is correct option. So next example, the range in which y is equals to minus x square plus 6x minus 3 is increasing is, here we have x greater than 3, less than 3, and in between 5 and 6 and 7 and 8. Now here we check the result. So increasing means f dash of x is greater than 0, or here we have y result dy by dx is greater than 0. See, first here because we have the result f of y is equals to minus x square plus 6x minus 3. Now here differentiate with respect to x on both sides. Differentiate with respect to x on both sides. dy by dx is equals to derivative of right hand side result. Derivative of x square is 2x minus 2x plus 6. This result is greater than 0. See, because this result is increasing, y is increasing. Increasing means, see, the result is increasing, dy by dx is greater than 0. See, dy by dx is greater than 0 means this term is also greater than 0. This implies minus 2x plus 6 is also greater than 0. See, this is inequality function result. Now here we subtract both sides by minus, subtract by 6, we get minus 2x plus 6 minus 6 is greater than minus 6, plus 6 minus 6 is cancelled. This implies minus 2x is greater than minus 6. Then divide both sides by minus 2. See here inequality, that is changes symbol. Here we get x is less than 6. Sorry, x 2x 6 divided by 2. Here we get 3. See, divide by minus 2. Minus 2 gets cancelled. We get 1x. Then minus 6 divided by minus 2. We get plus 3. But greater than becomes less than 3. X is less than 3. Option B is correct option. So here correct option, x less than 3 means when the range in which y is increasing for x less than 3. See, y is increasing for x less than 3. Option B is correct option. So next example, the minimum of 2x cube minus 3x square minus 12x plus 8 occurs at x equals 2. Here we have 4 options, minus 1, 2, root 6 and minus root 6. Here we check which option is correct. Now here we consider minimum of function. Here we consider y is equals to 2x cube minus 3x square minus 12x plus 8. See, now here we have to check the result is maxima, minima. Here we have to find the points, because at x means dy by dx is equals to 0 for maxima or minima. Then using that points, using, suppose we get quadratic equation or linear equations, using that point, if that point substitute in second order derivative. See, second order derivative d square y by dx square is greater than 0, we get minimum value. Suppose d square y by dx square less than 0, we get maximum value. This is minima, this is maxima. Here we using y first find dy by dx means dy by dx, then for maxima or minima, what happens here, dy by dx is equals to 0. Next, again differentiate this result, we get second order derivative. Then using this result, dy by x is equals to 0, we get roots of that equation. That roots of that equation, roots substituting second order derivative result. That result value is greater than 0, we get minimum value. Less than 0, get maximum value. Okay, this is the concept maxima or minima. Now we are using function y is 2x cube minus 3x square minus 12x plus 8. We are going to find dy by dx. dy by dx, differentiate with respect to x on both sides. Derivative of x cube is 3x square, 3 into 2, 6x square minus 6x minus 12. Then for maxima or minima, dy by dx is equals to 0. So dy by dx equals to 0. This implies 6x square minus 6x minus 12 is equals to 0. Here you can take common is, here we have 6, here also 6, here 12. This implies 6 is common term. X square minus x minus 2 is equals to 0. Next, here we have x square minus x minus 2. Find roots of this equation. Here we have coefficient of x square is 1, here minus 2, here 2 into minus 1. Otherwise we consider minus 2. See here minus 2 it is, here we have negative result, that's why here consider minus 2 plus 1. See, this result can be as 6 of, or negative 6 is not equal to 0. No need to write this 6 term constant. X square or minus 2x plus 1x or x minus 2 is equals to 0. Simplify the result, x common, x minus 2 plus 1 of x minus 2 is equals to 0. This implies x plus 1 into x minus 2 is equals to 0. Here we get the points x is 2, another one is x is minus 1. X is 2 and x is minus 1. Next step, using this result, now here we have to find second order derivative, b square y by dx square, derivative of this term, b square y by dx square is equals to derivative of 6x square, 6 is constant term, 6 into derivative of x square is 2x, 2 into 6, 12x, 12x minus 6. See, 12x minus 6, say suppose we consider x is minus 1, we get negative value. If the result is negative means less than 0. See, that is maximum. But here, find minimum result. That's why here consider x is 2. X is 2, what happens? 12 into 2, 24 minus 6 is 18. See, maximum value at x is equals to 2. See here, question is, here we have to find across at x is equals to 2. Here we get positive result. Positive means this result is greater than 0. See, this result d square by dx square is greater than 0 means minimum value. See, minimum at x is equals to 2. At x is 2 means option B is correct option. So next important result, the function f of x equals to 2x cube minus 15x square plus 36x plus 4 is maximum at x is 3, 0, 4, 2. Here also we consider same procedure. F of x, here we have 2x cube minus 15x square plus 36x plus 4. Now here differentiate with respect to x on both sides. Procedure is same. Find derivative of this result or dy by dx. Here we have function f of x, that's why you consider f dash of x. Derivative of this term is 6x square minus 30x plus 36, constant term is 0. Next step. Here for maxima or minima, d f dash of x is equals to 0. For maximum or minima, f dash of x is 0 means right hand side value is equals to 0, means 6x square minus 30x plus 36 equals to 0. Now here we can divide by 6 on both sides. What happens? X square 5x plus 6 equals to 0. Now here find roots of this equation. Here 6 into 1 is 6, 2 3s are 6. Here we have positive result, minus 3 minus 2 is minus, add the result minus 5. Here we get 2 comma 3. You can write directly the result. Roots x is equals to 2 comma 3, or you can write 2x minus 3x plus 6 equals to 0. Here x is common, x minus 2 minus 3 of x minus 2 is equals to 0. Say x minus 2 is 0, we get x equals to 2. Another one is x minus 3 is 0, x equals to 3, 2 comma 3 roots of this equation. Now here, find maximum value means here we have to find one more derivative term, f double dash of x. F double dash, second order derivative is equals to derivative of 6x square is 6 into derivative of x square is 2x. 6 into 2, 12x minus 30, constant term is 0. Now here check the result. At x is 2, another one is at x is 3. At x is 2 means here maximum is the result is less than 0. Now you don't need to write all these steps. You can check the result. X is 2. What happens? 12 into 2, 24. 24 minus 30 minus 6. See, minus 6 when the result f double dash of x at x is equals to 2, we get the result 12 into 2 minus 30. We calculate 24 minus 30 is minus right here minus 6. This result is less than 0. See, minus 6 less than 0 means that result is maximum. Okay, maximum at x is equals to 2. Suppose the result is greater than 0 is minimum. You can say another form. See, suppose at x is 3, check the result. What happens here? 12 into 3, we get positive result. When the result is positive, but then in that result we get minimum value. But here maximum value at x is 2. Option D is correct option. So next example, let the function f from R to R be defined by f of x equals to 2x plus cos x. Then f of x has minimum at x is pi, maximum at x is 0, is a decreasing function, is an increasing function. Now here we have function f of x. F of x is equals to 2x plus cos x. Then derivative of this result, f dash of x is equals to 2 derivative cos x is minus sin x. See, we know the domain of sin x. Domain of sin x is minus 1 comma 1. See, since the result minus 1 less than or equals to sin x less than or equals to 1. In between minus 1 comma 1. See, minus 1 less than or equals to sin x less than or equals to 1. Now here this result can be as 2 minus sin x is greater than 0. See, you substitute x is, say this value is minus in between minus 1 comma 1 for all x. For all x, this result is greater than 0. See, this 2 minus nx is greater than 0 means we know the function, we have this result 2 minus nx is also equals to f dash of x. See, f dash of x is greater than 0 for all x. See, we know the definition of an increasing function. See, increasing function means f dash of x is greater than 0. F dash, when the result f dash of x is greater than 0 for all x is, here we have the option minimum, maximum, decreasing. But here this result is increasing function for all x. Option D is correct. See, the interval in which the function f of x is equals to x cube minus 6x squared plus 9x plus 10 is increasing, is an increasing in, here we have 4 options. See, interval, the function is increasing means f dash of x is greater than or equals to 0. See, here strictly increasing or increasing function, where we consider f dash of x is greater than or equals to 0. See, now here first, here we have the data. Using f of x, find derivative of this result. Here x cube minus 6x square plus 9x plus 10. See, derivative of this result, f dash of x is equals to 3x square minus 6 into 2, 12x plus 9, constant term is 0. See, f is increasing function. Data, f will be increasing. F is increasing function. Increasing function. F dash of x is greater than or equals to 0. So this result is greater than or equals to 0. Means 3x square minus 12x plus 9 is greater than or equals to 0. Now divide by 3 on both sides. Otherwise, we can take common is 3. This result implies x square minus 4x plus 3 is greater than or equals to 0. Now simplify the result. Coefficient of x square is 1. Constant term is 3. This result can be as 3 ones are 3, minus 3 minus 1 is minus 4. X square minus x minus 3x plus 3 is equals to greater than or equals to 0. Now here, this result can be as, take common is x here, x of x minus 1 minus the 3 of x minus 1 is greater than or equals to 0. Next step, here we have x minus 1, here also x minus 1. X minus 1 into x minus 3 is greater than or equals to 0. See, here x minus 1 into x minus 3 greater than or equals to 0. Now here, this, here we consider interval form 0, x is 1, another one is x is 3 notation form. This result is greater than or equals to 0 form. So here we consider 1, 2, 3. X is 1, 3. Here we consider plus positive into this. Now here, this result greater than or equals to 0 means here we get minus infinity comma 1 open interval greater than or equals to 0. That's why I consider 1 union. This is 3 comma infinity open interval. This one ending open interval. This is closed interval. This is closed interval. This is open interval. See, option. Here we have D is correct option. See, because, oh sorry, here we have plus, here we have plus, but here we have negative. Option B is correct option. B, not D. Option minus infinity comma plus 1, 3 comma infinity, but here we have same term, but here we have negative result. It is not possible. Only option B is correct. Go to next. Here we have f of x is x to the power x has stationary point at the results. Here we have 4 options. F of x is equals to x to the power x. Differentiate with respect to x on both sides. See here using logarithmic functions form. Take log we consider y is equals to x to the power x. Already we discussed this result in theory class. You can write directly that result, or take log on both sides. Otherwise consider this result is equals to y. Y is equals to function x to the power x. Take log on both sides. Log y is equals to log of this result. We get x into log x. So using, otherwise I explain the result. Log of x to the power x. See, x to the power x means a to the power b form. This result can be as x into log x. You know this concept, you can write directly. Log y is equals to x into log x. Now here differentiate with respect to x on both sides. 1 by y into dy by dx is equals to u into v formula. X into derivative of log x is 1 by x plus log x into derivative of x is 1. So x get cancelled. Dy by dx is equals to y into 1 plus log x. See, dy by dx means f dash of x, or you can derivative of this result. F dash of x is equals to y is x to the power x 1 plus log x. See, at stationary point means this derivative is equals to 0. See, f is stationary. F has a stationary point. Stationary point means here we consider derivative is equals to 0. F dash of x equals to 0 means x to the power x into 1 plus log x equals to 0. See, x to the power x is not equals to 0. 1 plus log x equals to 0. Then log x is equals to minus 1. Then this result can be as x equals to e to the power minus 1. X is equals to e to the power minus 1, or this result can also be as 1 by e. X is equals to 1 by e. Option B is correct. See, f of x has a stationary point at x is equals to 1 by e. Option B is correct. So here we have the function f of x is equals to x square plus 2x minus 5. Strictly increasing means here we find derivative, then the derivative is greater than 0. Now here differentiate, derivative means differentiate with respect to x on both sides. Derivative of x square 2x plus derivative of 2x, 2 into derivative of x is 1, constant term is 0. See, strictly increasing, f is strictly increasing function. Strictly increasing means f dash of x derivative of this result is greater than 0. F dash of x is greater than 0. This implies 2x plus 2 is greater than 0. Now here, using inequality conditions, simplify the result. Subtract by 2 on both sides, plus 2 minus 2 is cancelled. 2x, here you can write plus 2 minus 2 greater than minus 2, plus 2 minus 2 gets cancelled, we get 2x. 2x equals to minus 2, divide by 2 on both sides. See here, on both sides, we get x is greater than minus 1. See, solution for this result, x belongs to, x is greater than minus 1 means minus 1 comma infinity. Minus 1 comma infinity. Option A is correct. So here, function f is strictly increasing. Derivative is greater than 0 means 2x plus 2 greater than 0. Here eliminated 2 or 2 transpose to right hand side, we get minus 2, or subtract both sides by 2 on both sides, plus 2 minus 2 gets cancelled, 2x greater than minus 2, then divide both sides by 2, we get x is greater than minus 1. Solution of this result is x belongs to minus 1 comma infinity. Option A is correct. Okay, thank you students. Continue next video.